So using the total entropy, we can also work out a temperature at which the reaction becomes feasible. So example, calculate a temperature range that this reaction will be feasible. Nitrogen is reacting with oxygen and it is forming nitrogen monoxide. The enthalpy change is 180. Then the entropy of a system is 25. As the reaction is feasible, the total entropy should be either 0 or more than 0. So means when we use this, we can say it should react the temperature at which the reaction becomes feasible. So total entropy should be greater than and equal to 0. That's a temperature. So what we can say, we can use the formula that the total entropy should be greater than or equal to 0. So minimum value we can take 0, but it should be more than 0. And we know entropy of the total entropy is the entropy of a system plus entropy of surrounding. So if this value is 0, so I can write 0 here. Entropy of a system is product minus reactant. Sometime you have to calculate, sometime it's given in the question, like in this example, it's given 25. So this value is 25. Plus entropy of a surrounding is minus delta H by T. So plus minus will be minus. So this will become minus delta H by T. And what is this delta H? Delta H is given 180. So just I have to solve. I will take I can move this to other side. So delta H by T is equals to 25. And or if I need T is delta H divided by 25. And in the question, there's a small, you can see here, it's written kilojoule. And here the entropy was in joule. That's why this converted into this delta H, what 180, but actually it's 180 exponent 3. All should be in the same unit, so you have to keep that in mind. And when you substitute, you will find about 7,200 Kelvin is a temperature at which this reaction will occur. So if this reaction occur at a very high temperature, this shows that the reactants are thermodynamically stable, because you need a greater amount of energy or you need a high temperature to carry out this reaction. Same way, as there is a physical phase change like a melting or a boiling, then the total entropy is also 0. Because what happened, the energy, in that case, the total entropy is 0. There's an entropy change for a system, but the total entropy, because what happened, if one is absorbing energy, for example, if I say a melting occur, so in case of melting, it is taking energy from the surrounding. So surrounding entropy will decrease and entropy of the system will increase. But if the total change in the entropy, or in that case, the total entropy, like if surrounding increase by 10, or decrease by 10, the system will increase by 10. So one is plus 1, plus 10, another one is minus 10. That's why the total entropy during a phase change is 0. So using this idea, we can also find the melting or a boiling point of a substance. So the question is, what temperature would the methane melt? A methane is solid, it is converting into liquid. So as we know, because there's a straight change, so what is the total entropy? That should be 0. So entropy of system plus surrounding, entropy of a system is given here in the question, and entropy of surrounding is minus delta H by T. So we'll substitute the value and we can find temperature at which this methane will melt. It's about 91 Kelvin. Is this clear? The two example, one is sometimes they ask state a temperature at which the reaction becomes feasible. So the temperature should be greater than an equal, the entropy change of a total entropy change should be greater than or equal to zero so that the reaction can occur. Or if we need a melting or a boiling point, that case also the total entropy is zero. Surrounding entropy will change, system entropy will also change, but the total entropy will remain unchanged during melting and boiling. Is this clear? Any doubt in this point? If something is kinetically stable, it has thermo. Look, for example, if I say for exothermic reactions, I can use the term thermodynamic stable for the product. So you have reactant. Reactant should form a product. Conditions are there, but still the reactants are not forming a product because they need a small amount of energy, which is called activation energy. Or even that energy is available in the atmosphere, but it's not taking in that phase. That's why the reaction may not occur. So what we use the term, we say for reactant, what we can say reactants are kinetically stable. And for product, what we can say, if the product is formed, then it means the product will be thermodynamically stable. So we use the term kinetic stable. If reactant can form a product, but they are not forming a product, so we can say the reactants are kinetically stable. But if the reaction occur and the product is formed, then the product which is formed is known as the thermodynamically stable. Because from product to form back the reactant again, they need higher activation energy. Is this clear? Then what is the effect of temperature on feasibility of the reaction? How temperature affects, as you know, like example, we have the total, it depends on whether a reaction is endothermic or exothermic, and then how it affects. If we say, first example, we say the reaction is exothermic. So if the reaction is exothermic reactions release energy, what is the value of delta H? Because the total entropy of system plus surrounding. So delta H will be positive. Delta H is negative, but it will make this formula positive because entropy of the surrounding is minus delta H divided by T. So minus delta H minus minus will be plus. So that the final will be positive. So this sign will be positive. Now you can see this reaction. If the total entropy, so if a reaction is exothermic, the total entropy will be entropy of a system. Entropy of a system can be positive, it can be negative. So if the reaction is exothermic and entropy of a system, example is positive. So this is always positive. This is also positive. So this reaction is spontaneous, or this reaction is feasible at all the temperatures. Means the change in temperature will not affect the feasibility of the reaction, because we want the total, for a reaction to be feasible, we want total entropy to be positive. So delta H is negative, 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 minus, minus will be plus. So the entropy of the surrounding is always positive for exothermic reaction. And if the entropy of a system is also positive, so this reaction will be spontaneous, or this reaction will occur at any temperature. So this reaction is spontaneous at all temperature. But what will happen if a reaction is exothermic and entropy of the system is negative? So if entropy of a system is negative, this will be negative. So what we want a higher value of this fraction, because this reaction, this is a positive fraction, so we want it to be positive, higher value. How I can have a higher value? If I need greater value of this fraction, whole fraction, then what I should do? I should decrease the temperature. So when I decrease the temperature, smaller denominator, so this fraction, this ratio will be higher. So this reaction will be spontaneous at low temperature. Means when the temperature is low, this reaction will be spontaneous. So for a reaction, if the system entropy of a system is negative and the reaction is exothermic, then it will be spontaneous at low temperature. But what will happen? This is when the reaction is exothermic and entropy of system can be positive or negative. So if a reaction is exothermic and entropy of a system is also positive, that reaction will occur at any temperature. But if a reaction is exothermic and entropy of a system is negative, so this reaction is only spontaneous or will only occur at low temperature. High temperature, it will be non-spontaneous. Is it clear? But what will happen if the reaction is endothermic? If the reaction is endothermic and entropy of the system is positive. So if a reaction is endothermic, and so this is minus delta H by T, the entropy of the surrounding, and system is positive, so entropy of a system is positive. I want this fraction, because this is a negative value, this will make the total entropy negative. I want this value to be smaller. So if I want this value to be smaller, I should increase the temperature. So this reaction is spontaneous at high temperature. And the last case, if the reaction is endothermic and the entropy of the system is negative, so this value will be negative and this is already negative, so it can never be spontaneous, because the entropy of the surrounding is negative and entropy of a system is negative. So when I add the two values, I will always get a negative answer. So it is non-spontaneous at all temperature. So you can work out whether a reaction is feasible at a certain condition depending on the nature or the type of a reaction and the entropy of the system. This is the whole thing what I explained to you. So example, now what is the effect of temperature on feasibility of a reaction? So example, if the reaction involve a decrease in entropy, hydrogen chloride reacted with ammonia gas, they form ammonium chloride. So if it is decrease in entropy, what is the entropy of the system? The system is negative. So what happened? We want this reaction to be spontaneous. So if we want this reaction to be spontaneous, so delta T is the entropy of a system plus entropy of the surrounding. Entropy of the surrounding is minus delta H by T. So I'm writing that directly. So system is negative in this example. And it depends on whether a reaction is positive, whether a reaction is endothermic or exothermic. If a reaction is exothermic, then this value will be positive. So system negative, this value is positive. So what happened? We should, if I decrease the temperature, the total entropy of a system will increase. So more likely we will have positive value for entropy of total entropy. So in this example, what happened? Like entropy of a system is negative, then increase in temperature, it's more likely, less likely that total entropy will be positive. Why the total entropy? Because if the reaction is endothermic, this minus delta H by T will remain negative. And if entropy of a system is also negative, even I change the temperature, but I cannot make this spontaneous. Then solubility of the ionic compound. For solubility of ionic compound, again, it also depends on the factor, the total entropy. If the total entropy is positive, the reaction will occur or it will dissolve. And if total entropy is negative, the reaction will not occur. Before understanding the concept of solubility, you have to recall the idea of a lattice energy. What is a lattice energy? When ions are there in the gaseous state, and these ions will form a compound. The energy which is released, because it's a bond forming is exothermic, and that energy is called lattice energy. Same thing when ions are surrounded by water molecule, ions in the gaseous state convert into ions in the aqueous state. They also form a bond with water molecule. We call that as hydration energy. And what is enthalpy of a solution? When a solid dissolve in water and dissociate into ions in aqueous, we call that as enthalpy of solution. So how we can calculate the enthalpy of the solution? What is the way to calculate enthalpy of solution? We can also use the Hess law to relate this lattice energy with hydration energy and enthalpy of solution. So as we have, like example, if I say sodium chloride is there in a solid state, it convert into sodium ion in a gaseous state, aqueous state, plus chloride ion in aqueous state. So when solid change to ions change to ion in aqueous, we call that as enthalpy of solution. I can say delta H. But maybe I have sodium ion in a gaseous state and I have chloride ion in a gaseous state, and they will form sodium chloride in a solid state. So if it forms sodium chloride in a solid state, we call this as a lattice energy. And when sodium ion and chloride ion in a gaseous state convert into sodium ion and chloride ion in aqueous state, we call that as enthalpy of hydration or hydration energy. So if I apply the Hess law, where the two arrows are pointing out, that's the start of the cycle. Where two arrows are pointing in, that's end of the cycle. So I can say the lattice energy plus enthalpy of the solution. So arrows are pointing out. So this plus this equals to enthalpy. So I can say enthalpy of a solution plus the lattice energy is equals to hydration energy. Or when I move to lattice energy other side, so I can say enthalpy of a solution is hydration energy minus lattice energy. But when you calculate the hydration energy and lattice energy, because both are bond forming is exothermic. So lattice energy is also negative and hydration energy is also negative. So in terms of values, and we want the answer, we want enthalpy of the solution, we want the enthalpy of a solution to be negative, because when the enthalpy of a solution is negative, the reaction means exothermic, so that reaction can occur or it can be spontaneous. But if it's an endothermic reaction, so then it cannot be, and delta H will be positive, so it will not be spontaneous at all the conditions. So enthalpy of a solution is hydration minus lattice energy. So if enthalpy of a solution is coming out negative, it means the substance will dissolve. And if enthalpy of a solution is positive, then the substance will be insoluble or it will not dissolve. Then we have, this is at that specific temperature, we will find the total entropy, and we can identify from total entropy the solubility as well. So if we want to calculate enthalpy of a solution, it is hydration energy minus lattice energy. And the trend in the lattice energy, you have to recall that trend, how the lattice energy changes. The lattice energy become less negative, like lithium chloride, sodium. What is the reason for that? Because like example in lithium is a smaller charge, means a small size. So it has greater attraction towards the chloride ion as compared to sodium. So as we go down the group for the compounds for metals, as we go down, as the size increase, the lattice energy will decrease. So lattice energy is higher when the charges are smaller in size. Both should be smaller. And when there's a greater charge on them, it will have higher lattice energy. Like example, when you compare calcium oxide with calcium sulfide, sulfur is below oxygen. So sulfur is having a greater size as compared to oxygen. So oxygen, calcium oxide will have a higher lattice energy, and calcium sulfide will have a lower lattice energy because ions are bigger in size. So weak attraction between the ions. So to have a higher lattice energy, ions should be smaller in size and the charge on the ion should be more, so that they have greater attraction towards each other, which leads to higher active lattice energy or energy release when they will react with each other. This is just now I discussed with you the enthalpy of a solution, how to calculate the enthalpy of a solution. Example, you have magnesium chloride solid. You add to water, it becomes magnesium ion in aqueous and chloride ion in aqueous. We call that as enthalpy of solution. Or you have magnesium ion and chloride, or you have say this magnesium ions and chloride ion in gaseous, it become solid. So this is called a lattice energy. Or magnesium ion and chloride ion become aqueous, that's called hydration energy. So enthalpy of a solution is lattice energy. It's written like minus lattice energy plus hydration, or hydration energy minus lattice energy. So when ionic substance dissolve, the lattice energy must be broken, because what happened, how the solubility, the concept use here, say if we have a sodium chloride crystal, so these ions are tightly packed together. They have a regular arrangement. That arrangement is known as a lattice. So magnesium chloride is there, or sodium chloride, NaCl. So to break this, the lattice energy, definition of a lattice energy means energy released when ions form a compound. That's the definition of lattice. But what happened if the lattice energy is 100 joule per mole? The hydration and the energy required to break the lattice will be same as well. Like example, if 100 joule is released when this lattice is formed, so to break the lattice I need 100 joules as well. And from where this 100 joule will come? It will come from hydration energy. When we add a solid or a salt to water, the ions will attract each other and form a bond. So when ions will form a bond, that release energy, if this hydration energy is higher than the lattice energy, then the substance will break down, or lattice will break down and it will dissolve. But if lattice energy is higher than the substance, then the hydration energy, then the substance will not dissolve. So this is the same idea about lattice energy. So if a question is calculate enthalpy of a solution, given that the sodium chloride lattice energy is minus 771 and enthalpy of hydrogen is 364. So formula is hydration minus lattice or minus lattice plus hydration. That's the same thing. So you will substitute the values accordingly. You substitute minus is for the formula, and the formula of lattice value of a lattice energy is minus 771, and hydration energy is minus 406 and 364. This is sodium chloride, so it contains one sodium ion and one chloride. But what if, for example, if it was magnesium chloride, then for magnesium, because it will form one ion, so we'll not multiply by any number. But for chloride, because in magnesium chloride, there are two ions, so then the hydration energy for chloride ion should be multiplied by 2. So when we calculate, it's coming out a positive answer. So if it's coming out a positive answer, it shows that this substance will not dissolve by itself easily. We have to change the condition. Either we have to increase the temperature so that the reaction can be spontaneous. Then the hydration energy. The hydration energy depends on the charge density. Charge density like charge per unit volume. So fluoride ion have a higher or more negative hydration energy because fluoride ion is smaller in size, so more attraction towards the oxygen ion. That's why greater amount of energy release. And same thing, magnesium ion having a more negative hydration energy than barium ion because magnesium ion is smaller as compared to barium ion. So for hydration energy to be higher, the charge density should be greater. Charge density greater means smaller volume, and higher charge will leads to greater hydration energy. So basically what enthalpy of a solution? So normally when enthalpy of a solution which we calculate, it's not very exothermic or endothermic. So in general, the substance more likely to be soluble if delta H or enthalpy change of a solution is negative. If a substance is insoluble, it doesn't. It is often because the lattice in energy is higher than the hydration energy, and if it is not energetically or kinetically break down, it means enthalpy of a solution is making endothermic. So for the in short, for a substance to be soluble, the enthalpy of a hydration energy should be higher than the lattice energy. And the total entropy should be positive. So what happened, for example, for a salt where the enthalpy of a solution is exothermic or delta H is negative, so this value will become positive. So this is positive. So salt will dissolve at all temperature, and this is already entropy of a system, because when the salt dissolves, entropy of a system will be positive because there are more ions, more particles in a solid state, less random move. There's no random, there's vibratory motion, but no random movement. But when it dissolves, it will dissociate into ions. So more charges are more particles or distribution of the particle. That's why the entropy increases. Same way, if a reaction is endothermic, so if a reaction is endothermic, this value will be negative. And entropy of a system should be positive. So how we can make it feasible? So we want this value to be smaller. If we want this value to be smaller, then we should increase the temperature. That's why the salt will become soluble as a total entropy will be positive. So at what condition the total entropy is a positive? When at higher temperature. Is it clear? Now some questions related to entropy and the rate of the reaction. So example, which reaction has the most positive entropy? What could be the answer? Which reaction is having the most positive entropy? Everyone should participate so that it shows your understanding of the topic. D is the right answer because you have both gases, two particles or moles of a gas. So this is qualitative analysis. You did not, without calculation, you just mention what happened. The barium carbonate decomposed in endothermic reaction and was heated to 1500. What are the signs for entropy change at 1500? What could be the answer here? Barium carbonate decompose endothermic. Look, you can see there's a solid in the reactant side, but you have solid and gas. So entropy of a system should be positive. But it's an endothermic reaction, so entropy of a surrounding should be negative because entropy of a surrounding is minus delta H by T. And delta H is positive, so the entropy of a surrounding will be negative. That's why B is the correct answer. Which of these solid substance likely to have the greatest standard entropy? What could be the answer? Yeah, these, because having greater number of particles, so D is the right answer. The equation for enthalpy change of hydration of magnesium. Hydration means when ions in the gaseous state become ions in aqueous state. What is the answer? So B is the right answer for this. Energies evolve when 1 mole of a gaseous calcium ion is hydrated. This reaction is more exothermic than corresponding value of barium. Why the hydration energy is higher? Because for calcium is higher than barium, because calcium is smaller in size and same charge. So what's the answer? So ionic radius of calcium is smaller than of barium. So D is the right answer. The following cycle represent the enthalpy changes which occur when ionic solute dissolve. Which of the following change is a lattice energy? Lattice energy means when ions in the gaseous state will convert into ions in a solid state. Sorry, compound in a solid. So this is solid change to aqueous is W, but negative, this will be minus W. So B is the right answer. Energy given out when 1 mole of a gaseous strontium ion is hydrated. This energy is less exothermic than corresponding magnesium. Why magnesium is giving more energy as compared to strontium? What's the reason for that? Basically, hydration energy is more. So why? Because magnesium is smaller in size, so higher hydration energy.